Okay, so I have completed the first six distance measurements here, and I was noticing a pattern as I was going along. Coordinates A, B, C, and D all had 5 and 0 or negative 5 and 0 in them. So when I square those values and add them together, in every case we got the square root of 25, which gave us a distance of 5. And now I've completed part E and part F, and I'm working with a 3 and a 4, and then a 4 and a 3. The order of adding them together doesn't matter, and I get the square root of 25 again, and I get a distance of 5 again. My prediction is when we do part G, we're going to have the same thing happen here. If I do D for distance is the square root of, and I put the negative 3 in brackets, and I square that, that's still going to give me a positive 9. We're going to get 4 squared here and a positive 16 out of that. Sorry, I had a little interruption there. But what I'm noticing is I have a 9 plus a 16, and that gives me the square root of 25, and again, I get 5 as an answer. So in fact, all of the rest have variations of 3 and 4, either with positives or negatives. In every case, we should get our distance being equal to 5 when we do those. So if you did not get your distance to be 5 every time, yeah, you should have. So check your work. We probably have a little error somewhere if you didn't get 5 every single time. Now, for number 2, I've asked you to plot each of the above points on the Cartesian plane. So if you have not done that, please do that. And then join those points together with a smooth curve. Okay, and then we'll talk about what happens there on the next slide. Okay, once I plotted my points and I joined them together as best as I could with the stylus here, I got something that reminded me of what should be a circle. Now I think my proportions are maybe just a little bit on my graph when I imported it. It shouldn't look oval, it should be an exact circle, because every single one of these points has a distance that is 5 centimeters from the origin. So every single one of these that I'm drawing in, these are radii. They're radiuses for our circle. So once we join all those points, that creates a circle. And in fact, this circle, like when we do lines, it has its own equation. And the equation in this case was that we can take any x value and square it, plus a y value and square it, and for every point that would lie on this circle, the radius or the distance, every single point's distance is from the origin, is 5 units away. So if I take my x coordinate and square it, and I add my y coordinates squared, the answer will be 25, and the 25 really is the radius squared. So like y equals mx plus b is our equation of our line with a slope of m and a y-intercept of b, this is the generic equation for any circle with a center at 0, 0 and a radius that is r units long. So that's what's defined on the next slide here. The distance formula for any point from the origin is that d is equal to, we're going to square it on the next one, the square root of x squared plus y squared. And if we square both sides of the equation, we get that d squared is equal to x squared plus y squared. A set of points that are all the same distance from the origin will form a circle. They all have the same distance. That forms the radiuses, and the radii are all the same length. That makes a circle. The equation for a circle with a center at 0, 0 and a radius of r will look like this. It'll be x squared plus y squared, and the only thing you're filling in is what you know for the r value. Okay, that's any circle with a radius of r, and its center would be at 0, 0. So question 1, determine the equation of a circle with a center at 0, 0 and a radius of 3. That means its equation would be x squared plus y squared equals 3 squared. And 3 squared we can actually evaluate, so its equation will be x squared plus y squared equals 9. Okay, try the next two. Though for the part B has a radius of 4 over 3, and part C has a diameter, this is diameter, D for diameter, of 18. So just keep that in mind when you're working on that. Okay, if you check this, you should have had x squared plus y squared equals, and then you're going to have 4 over 3 all squared. And 4 over 3 all squared, you just square the 4, which would be 16, and square the 3, that would give you 9. So our radius squared is 16 over 9. For part C, the diameter was 18. That means the radius is half the diameter. The radius should be 9. So our formula for the circle with a center at 0, 0 and a diameter of 18 would be x squared plus y squared equals 9 squared. And 9 squared is going to be 81. Okay, number 2. Determine the radius and the x and y intercepts of the following circles with the center at 0, 0. So this value of 64, that represents the radius squared. So if the radius squared is 64, so r squared is equal to 64, to get the radius will be the square root of 64. And the square root of 64 is 8. Now I ignored the negative square root because when we're talking length, we only really need to worry about the positive length. Now it's asking for the x and y intercepts. If your radius is 8 and your center is at 0, 0, so I'm just going to try and draw a circle as best as I can there. The radius is 8. It means from the center to the outside would be 8 units. So my y-intercept, one would be at positive 8. The other one would be down here at negative 8. My x-intercept, one is at positive 8, and the other one would be at negative 8. So my x and y intercepts are going to be negative 8, 0, and 8, 0. Those are my x-intercepts. And my y-intercepts, so these are x-intercepts, my y-intercepts would be 0, negative 8, and 0, positive 8. Okay, try the next two and see how you do. Okay, for part B, our radius is radius squared is equal to 1. Square root both sides. We're going to get radius is 1 unit. Square root of 1 is just 1. And then if I were to draw the circle with a radius of 1 with a center of 0, 0, I would have my x and y intercepts at negative 1, and at positive 1 on the y, and at negative 1 down here. So in terms of x-intercepts, we have negative 1, 0, and we have 1, 0. The y-intercepts are 0, 1, and 0, negative 1. The next one, we have r squared, the radius squared being 8. So the radius will be the square root of 8. I'm going to leave that in exact form because it doesn't work out to be a very wonderful decimal. It's a non-terminating, non-repeating decimal. So I'm just going to make my x-intercepts the negative square root of 8, 0, as well as the positive square root of 8, 0. Those are my x-intercepts. For my y-intercepts, my x equals 0, so it'll be 0, negative root 8, and 0, positive square root of 8. Hopefully that makes sense.